Welcome back. Today we're going to start talking about solving quadratic equations. So before we get started with our first method of solving a quadratic equation, what I would like you to do right now is to pause the video, graph these two. So again, if you have just a piece of coordinate graph paper, or you could take a regular piece of graph paper and just graph those two. Notice we're kind of going back a little bit. There's not a bx term in there. That's okay. And then I want you to estimate, about how much would the square root of 5 be. Again, we're doing principal square roots, which means only the positive. We know that when we take a square root, there are two roots, but we're just looking for the positive. So the square root of 5 is about how much, and I'm asking you to guesstimate it without a calculator. 40 would be about how much a square root of 40 and square root of 8. So I'm going to ask you to pause the video and to kind of do those three things, and then we'll come back and see how you did. Okay, guys, so let's check out these graphs and these square roots. So when you graph this, you should have got your vertex to be 0, -9. That -9 is where the parabola is going to hit the y-axis. Happens to be also the vertex because there is no bx term, as we talked about in our last video. It opens up because the a is positive, in this case +1. You could have found that vertex of -9, 0, -9, by doing the negative b over 2a, but in this case b is 0. So you would have gotten an x of 0, the x-coordinate of the vertex, and if you put the 0 in and squared it, you would get the -9. So negative b over 2a will always give you the x-coordinate of the vertex. It's just not necessary in this case. We're a little bit smarter and can realize that it's going to be positioned there. Today I want you to not just look at that vertex. I want you to start getting your eye on where does the parabola cross the x-axis. So I want you to look at that point and that point right there. We're going to have our eye on those more today. Okay. All right, the second one should have had a vertex of 0, 5, opening up again. And again, I want you to get your eye on the x-axis and ask yourself, where does this parabola cross the x-axis? Well, Mrs. Woodruff, that's a silly question. It doesn't. Well, let's notice that. So we're going to be talking about the solutions, which are going to have something to do with what I'm introducing you when I get your eye on that x-axis. Okay, today we're going to be using our square roots again. We'll be using the calculator, but I just wanted you to get in your brain again, the idea of a square root. So the square root of 5 is not a perfect square. The square root of 4 would be 2, and the next perfect square would have been 9, which would be 3. So we know that the square root of 5 has to be somewhere in between 2 and 3, because it's 5 is in between the two perfect squares of 4 and 9. And it's slightly bigger, so it is about 2.2. Square root of 40 would be in between the two perfect squares of 36, which the square root of 36 is 6. 49 is the next perfect square above, and the square root of 49 is 7. This guy's somewhere in the middle. It's about 6.4, and if you do take the square root in your calculator, you can verify that. Square root of 8 is right below 9, which square root of 9 would be 3. We know it has to be just smaller, so it's about 2.9. Just want to get your idea again that a square root is not just dividing the number by 2. It's what number squared gets you back to the number that you're asking for. Okay, so today, let's just quickly review the ideas of graphing. We know that the x-coordinate of the vertex is negative b over 2a. We know that the a will tell us whether it opens up or down and kind of give us an idea about the width of the function compared to the parent function. We know that we can get the x-coordinate of negative b over 2a of the vertex, and then if we put that x value back in, we can find the y-coordinate. And we use 2 points on either side, 2 x values on either side of the vertex to kind of determine the shape of the parabola. And that's what we've been working on for the last several days. We just did a kind of a quick review of square roots. Remember that every positive number actually has two square roots, a positive and a negative, the positive called the principal root. Many square roots are not nice numbers. They don't come out to 2. They're irrational numbers. If you remember pi stretching across the classroom, an irrational number is a number that will go on in that decimal form, never repeat, never end. And remember that a square root of a negative number is undefined because there is no number times its identical twin that will give you a negative number. 3 times 3 is 9, but -3 times -3 is also 9. So the square root of a negative number is undefined. Just some things that we want to pull together today as we go forward and start talking about solving quadratic equations. We're in the latter part of Unit 8, and please note that this corresponds to your textbook, Chapter 10, Section 3. Okay, today we will learn how to find the solutions to quadratic functions. So what is the solution of an equation? We just need to think way back. Basically, that's the value, or today you're going to notice values, of the variable or variables that make the equation true. So we're looking for the solutions to an equation, and today we're going to see that our squared is going to be in there because these will be quadratics. All right, so definition. Solutions to a quadratic function are also known as the roots. So the roots is the same, is a synonym as the word solutions. And it means the values of x when y equals 0. So the solutions of a quadratic are going to give you the points or point, as we'll see. There can be that special case where the parabola crosses, intersects with the x-axis. Now you're going to remember that the x-axis has the equation y equals 0. It is a horizontal line, which means it's y equals a number, and it is 0. So y equals 0 is the equation of the x-axis. So the values of x when y equals 0 is what we're looking for. So on the graph, these are the x-coordinates of the points where the parabola crosses the x-axis. So there are two ways to find the solutions, also known as roots, to a quadratic function. You could graph it and see where the parabola crosses the x-axis, but the problem would be, what if those are not integers? It's not bad if you had a graphing calculator, but it can be nearly as impossible when you're doing it by hand. So instead, what we're going to do is we're going to take our quadratic function and we're going to take the y out and we're going to substitute 0. Because remember that the equation of the x-axis is y equals 0. So we're going to replace the y with a 0 and we're going to solve it for x. Since the solutions to a quadratic functions are the values of x when y equals 0, we're going to simply substitute 0 in for y in the original equation, and we're going to solve for x to find the roots, oh, by the way, solutions. So let's start with this one. This is a quadratic equation. It has an input and an output, an x and a y. And we want to know what are the solutions. We're not looking for the vertex now. We are looking for where does this parabola cross the x-axis. In order to do that, we're going to substitute a 0 in for y. Y equals 0 is the x-axis. So the y is going to leave the equation and 0 is going to go in. And we now have an equation with one variable. We're going to solve this for x squared. So the first thing we're going to do is add 9 to both sides. And we've come to this point. Now the opposite of squaring is to take the square root, not divide by 2, take the square root. The square root of x squared will just give us x, and the square root of 9 is going to give us 2 roots, 2 answers, 2 solutions, plus or minus 3. And we have just solved that quadratic equation. If you go back into the original and substitute 3 squared is 9, and 9 minus 9 would give you the 0. Negative 3 squared is also 9, positive 9. Minus 9 gives you 0, so you can see that that makes that true. But what does this mean? So what does x equal plus or minus 3 mean for the original problem? Just think about that. What did we just find? Well, guys, here is the graph of y equals x squared minus 9. Remember that that negative 9 is the vertex. It's way down here. There's a negative 9 on the x-axis. It's 0, negative 9. That 3 and negative 3 that we just got from solving are the 2 points that that parabola hits the x-axis. They're called the solutions, but that's what they are on the graph. So let's try another one. Y equals x squared minus 16. We're going to solve this for x, but the first thing we need to do is we have two variables in there, is we're going to substitute. We're going to take out the y and put in 0, which represents the x-axis. And now we're going to solve this quadratic equation. We're going to add 6 to both sides, 16 rather, and then we're going to take the square root and we get plus or minus 4. And again, these 2 points, 4, 0 and negative 4, 0 will be the points on the x-axis where the parabola intersects. Well, what about this one? Now, wait a minute. Same method. We're going to replace the y with 0 to represent the x-axis, and we're going to solve this quadratic function. It just happens to be a two-step. We're going to add 12 to both sides. But this time we're going to divide both sides by 3. And now we'll take the square root. And when we take the square root of both sides, we'll get plus or minus 2. So if we were to graph this parabola, we know that it's opening up. And we know that it's going to hit the x-axis at positive 2 and negative 2. We could find the vertex if we came up here and did negative b over 2a. In this case, the b is 0, and it would be 0 over 6, so the x-coordinate would be 0, and if we plug in 0, the y-coordinate is negative 12. So the vertex is 0, negative 12. So we know that, we know it opens up, and we know it's going to hit the x-axis at a positive 2 and a negative 2. And here's exactly what I just mentioned. So there are the two solutions, and way down here off the graph, because my graph doesn't go all the way down there, is the negative 12. Okay, so let's talk about this one. We're getting good at this. We're going to substitute 0 in for y, and we're going to solve the equation. Okay, we're going to add 10 to both sides. We're going to divide by 2. And when we go to take the square root, oh no, 5 is not a perfect square. So we're going to pick up our calculator. We're going to take the square root of 5. We're going to get that to be about, there should be a plus or minus that 2.24. How about this one? I'm going to put 0 in. Okay, I'm going to divide both sides by 5, and 0 divided by 5 is 0. The square root of 0 is 0. There is no plus or minus here, so there's only one answer. So what's going on here? Well, let's take this graph over here and show you what's going on. The vertex is sitting right on the x-axis, so there's only one solution in this case. The parabola opens up because there is a positive 5 here. And when we solved it, we got a 0. But we knew that. We knew that a parabola that doesn't have the bx term or the c is vertexed at 0, 0. But here you can see that the math is showing you that as well. So there's only one solution in this case. Okay, let's take a look at this one. We're going to substitute 0 in for y, representing the x-axis. We're going to subtract 4 from both sides. But right now, when we go to take the square root of a negative, we got a problem. The answer is not 2 and negative 2, guys, because the square root of negative 4 is an impossible situation on the real number system. So we've got an undefined. So what is going on here? Well, think about this. this parabola has a vertex at positive 4, right? There's no bx term in there, so we can see it, and it's doing that. So what are its solutions? Where is it hitting the x-axis? Not happening. So in this particular case, it's undefined, and that's what the picture looks like. So what does it mean to have the solution that is undefined? So basically it means that the graph is above the x-axis and opens up. So if you had a picture like this, that would give you an undefined situation. Or the graph is below the x-axis and it opens down, something like this. And that's where you get the undefined. So there are basically three possible solutions here that can happen. You can get two solutions, and it could look like this. It could be opening down, and its vertex is above the x-axis, or like the other ones we did, it's opening up, and its vertex is below. You can have one solution, its vertex is sitting on the x-axis, or you can have no solutions, and we just talked about, the possibilities there. So remember that the places that the graph crosses the x-axis are called roots. So you can have two roots, one root, or no roots. So for the following quadratic functions, I want to see if you can find out how many solutions each one has and what they are. So there are 5 examples right here for you to solve. And I'm going to ask you to go ahead and do those, and we'll come back in just a second. So pause the video. Okay, let's see how you did. So in the first case, in all of these, you're going to put a 0 in for y to represent the x-axis, and then you're going to solve the equation. You would have added 8 and divided by 2 and would have had x squared equals 4. When you take the square root, should have gotten plus or minus 2, and there would be 2 solutions. Here, you would have put the 0 in, subtracted 20 and divided by 3. You'd have a negative number over here. When you take the square root of a negative, that would be undefined. So this is no solutions. This parabola is opening up, and it's vertex above the x-axis, so it never touches the x-axis. The next one, you would have put a 0 in, divide by 4. 0 divided by 4 is 0. You've got x squared equaling 0. The square root of 0 doesn't have a plus or minus. There's only one answer, which is 0. There's only one solution. This parabola is opening up, but its vertex is sitting on the x-axis. It's actually at the origin. You would put a 0 in for y. You would add 9 and divide by 3, and you'd have x squared equals 3. The square root of 3 is about plus or minus 1.73. 2 solutions. This parabola is vertexed below the x-axis. It's opening up, and it's going to hit the x-axis at 2 places, where x equals negative 1.73 and where x equals positive 1.73. The last one, you're going to subtract 125 and divide by negative 5. So a negative 125 divided by negative 5 will give you a positive 25. You're going to have x squared equaling 25. The square root of 25 is plus or minus 5, and there are 2 answers. This time the parabola is opening down. Look at the a, the negative a. The vertex is above the x-axis, and it's going to hit the x-axis in 2 places, at negative 5 and positive 5. So that's just giving you an idea of how to solve a quadratic equation using square roots. Now, it would be great if that was the end of our year and we could use square roots for everybody, but obviously something is up. And if you look at all the cases that we are doing right here, you might notice something is missing. Think about that. More on that to come. Have a great day, everybody.